The next generation of LED drivers require more features and higher performance than ever before. Higher efficiency prolongs battery life and reduces heat in space-constrained applications. Wide voltage ranges are needed to accommodate the many sources of energy and combinations of LEDs. Automotive converters must have low EMI. High PWM dimming ratios are needed for day and night display brightness control. Long off times are needed between PWM pulses for machine vision and camera flashes. And all of these need the most advanced fault protection with the least number of components possible. Linear Technology's new LT3922 LED driver meets these demands. Hi, my name is Szolusha. I am an Applications Engineering Section Leader at Linear Technology. Let me introduce you to the LT3922, a synchronous, low EMI silent switcher LED driver with internal PWM dimming. Its synchronous 40-volt, 2-amp power switches are contained within its very small 4mm by 5mm QFN package. Its switching frequency range starts at 250 kHz and reaches up to 2.5 MHz. Its LED brightness can be adjusted with either an internally generated PWM signal or an externally provided signal. It has advanced short circuit and open LED protection. Our patented silent switcher architecture and the LT3922's spread spectrum frequency modulation minimize its EMI. The LT3922 LED driver can be configured as a boost, a buck, or a boost buck LED driver. The low EMI silent switcher architecture of the LT3922's synchronous integrated switches remains intact in any of these topologies. The change from boost topology to the boost buck topology involves adding another winding and output capacitor and connecting the LEDs to a different LED minus node. The LT3922 boost buck can drive 15 volts of LEDs at 330 milliamps from a 9 volt to 18 volt source. It passes CISPR 25 Class 5 with its low EMI hot loop and low input and output ripple. LT3922 can also be a buck LED driver. A single inductor and a different VN connection make a high bandwidth buck LED driver with the same low EMI hot loop. From 8 to 36 VN, the LT3922 drives 1 or 2 1-amp LEDs in buck mode with up to 5,000 to 1 PWM dimming. The LT3922's demonstration circuit is a small 2 MHz boost that can power up to 34 volts of LEDs at 330 milliamps from 4 to 28 VN with over 90% efficiency. This low EMI demo circuit passes the stringent CISPR 25 Class 5 automotive spec. Radiated EMI can be measured with a large biconical or log periodic antenna inside an anechoic chamber like this one. These special walls provide an environment without echo to ensure that only direct field radiated emissions are measured. With the LED load on and the chamber secured, the low EMI LED driver passes both peak and average radiated EMI. The LT3922 also passes CISPR 25 Class 5 conducted EMI. The fundamental EMI component of 2 MHz switching frequency resides above and outside of the AM radio band requirement. The converter's spread spectrum frequency modulation allows it to also be used at frequencies below the AM band by reducing the EMI of its main harmonics. Higher switching frequencies use smaller inductors and EMI filters and give higher PWM dimming ratios. Lower switching frequencies give the highest efficiency and handle the most power with the lowest temperature rise. The LT3922 can generate its own PWM dimming signal internally. An adjustable DC voltage on the PWM pin is all that is needed to generate up to 128 to 1 PWM brightness control. When higher dimming ratios are needed, The LT3922 still accepts an external PWM signal. The LT3922 can provide PWM or flash pulses at exceptionally low frequencies or long off times. Short PWM pulses remain high quality and accurate with very long off times for machine vision or other flash and camera devices. The LT3922 synchronous LED driver meets the demands of tomorrow's LED lighting apps. Its high efficiency and PWM dimming, combined with its low EMI and small size, make it ideal for a broad spectrum of solutions. Despite its small size, the LT3922 is filled with robust protection features. Please visit us at linear.com for more information. Thank you.